All right, if you think we've been on easy street so far, we're about to take a hard left onto difficult avenue, so watch out. Let's suppose that we had our original parent function, f of x equals x cubed, and we have a different little modification. G of x is x minus 1 in parentheses cubed. Now this is not the same as x cubed minus 1. Remember, we just saw x cubed minus 1. That'll be a vertical translation down by 1. It's not what's happening here. So, what's going on with g of x? Let's fill out our t-chart and see what happens. G of negative 3, I'll write it over here, is negative 3 minus 1, then cubed. Negative 3 minus 1, negative 4. Cubed, huh? Well, it's negative 4 times negative 4 times negative 4. Positive 16 times negative 4. I've never seen such numbers before. That's negative 64. That's what we put here. Okay. What about g of negative 2? Oh, I'll just do it right here. So it's negative 2 minus 1 cubed. So negative 2 minus 1, negative 3. Negative 3 cubed. I think we did this already. Negative 27. So that's what we put there. And we can fill out the rest of the table similarly. So negative 1 minus 1, negative 2. Cube it, you get negative 8. 0 minus 1 is negative 1. Cube it, you get negative 1. 1 minus 1 is 0. Cube it, you get 0. 2 minus 1 is 1. Cube it, you get 1. And 3 minus 1 is 2. You cube it, you get 8. Oh. Maybe some of you are a little observant. You might have noticed a pattern here. This column is the same as this column, except it's translated down by 1. Very observant if you caught that. Anyway, onto the graphs. F of x, I drew for us. We already suffered through that. No need to do that again. Now on to g of x. Okay, so first point, negative 3 comma negative 64. That means left 3, down 64, to the floor. I'm not going to attempt to draw that here. Next point, negative 2, negative 27. Left 2, down 27. Okay, that's kind of, I don't know, there. Next point, negative 1, negative 8. Okay, negative 1 and down 8. We can manage that. Oh, look, it ended up right next to this red point. Next point, 0, negative 1. So we don't move at all, and then we go down 1. That's also just to the right of that red point. 1 comma 0, right 1, up 0. Just to the right of that point. And 2 comma 1, right 2, up 1. And 3 comma 8, right 3, up 8. And finally we connect the dots. That's g of x. Okay, maybe you already guessed the pattern here. Each of these blue points is the corresponding red point shifted right by 1. Okay, so whatever point this is, that's this point shifted right by 1. So remember, when we added or subtracted things at the end of the function, that was a vertical translation, up and down. Here we're adding and subtracting from x in parentheses. That's a horizontal translation. So this is a horizontal translation. But are we going right or left? Well, we started with the red curve, the parent function, and ended up with the blue one. So we went right by 1. A little surprising and maybe a little counterintuitive. Horizontal translations work the opposite of what you might think. When you have a negative sign, it means move the graph right by that amount. When you have a positive sign, it means move it left. That's sort of opposite of the way that vertical translations work. Anyway, let's see if we could plot some more of these guys. Okay, so imagine we had, again, some more functions. Let's say we had h of x is x minus 2 cubed. So we look at the parent function, the red one, and we have a minus 2, that's a right by 2. So instead of moving it right by 1, we'd be moving all these points right by 2. And then we'd connect the dots. So that would be the graph of h of x. And if we wanted specific points on it, we would just have to move the corresponding point right by 2. So for instance, 0, 0 was on the parent function. If I move that right by 2, I get 0, 2. 2, 8 was on the parent function. If I move that right by 2, whoops, sorry. This should be 2, 0. Moving it right by 2 means we increase the x value by 2 and leave the y alone. If I take 2, 8 and move it right by 2, that would be 4, 8. We increase the x value by 2, leave the y value alone. And then this point, -2, -8, would be 0, -8. I add 2 to the x, leave the y alone. Okay, you get the idea. And finally, I had k of x is x plus 3 cubed. Well, plus sign means you move it left by 3. So you take the original function, this red guy here, move the whole thing left by 3. 1, 2, 3, move this 1, 2, 3. Then 1, 2, 3. Okay, you get something like that. That'll be k of x. Any questions? I sure hope not, because this was just explained. Thanks for watching.